Hello students, welcome back to my channel. So today we are going to cover CBSE Board Grade 10, the first chapter, that is real numbers. So this is going to be the part 3 video. So already I have uploaded 2 videos for real numbers. So if you haven't watched yet, so please watch it first, then come to this part. Otherwise, you will not be able to understand this video. Okay. So in the previous video, we have seen how to apply Euclid's division algorithm. So we will continue with that and we will solve some more problems. So let's take a look at the first question. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So Euclid's division lemma and algorithm both are same. So whatever you know that A equal to BQ plus R, you have to apply that formula or that algorithm. Okay, so now let's take a look how you're going to solve it. So in the previous video, I have already shown you how to solve this type of problem. So in this case, the question is bit different from the earlier one. Here they are saying that the square of any positive integer is in this two forms. Okay, so that means any positive integer square should be in the form of 3m or 3m plus 1. So let's denote the positive integer as x. Okay. So let x be any positive integer. So now since they are asking that this square of the positive integer will be in the form of 3m or 3m plus 1. So here we will consider the divisor as 3. Okay, that is the b. So b is here 3. So now applying Euclid's division algorithm, a equal to bq plus r. So we will get x equal to 3q plus r, where r is 0 greater than 0 less than equal to r less than b. So that means r value will vary from 0 to less than b. So here b is 3. So the possible values of r will be 0 less than equal to r less than 3. That means the possible value of r will be 0, 1 and 2. So the possible remainders will be here 0, 1 and 2. So now x is equal to 3q plus r. Instead of r, if we replace the possible values, that is 3q plus 0, that is 3q, or 3q plus 1 and 3q plus 2. Now in the question, they are asking for the square of the positive integer. So we have considered x over here. So x is the positive integer. So now if we take x equal to 3q, then we need to square the value of x, that is x squared. So if we do x square, that is equal to 3q whole square, that is equal to 39 square. So my mistake, that will be 3q square is equal to 9q square. So 9q square we can represent it in form of 3 into 3q square, right? So 3q, if we consider 3q square as m, then it is in the form of 3m. If we consider that 3q square as m, then it is in the form of 3m. Okay. So one form we got, that x square is in the form of 3m, where for some integer m, where m is equal to 3q square. Now we have to consider x equal to 3q plus 1. So if it is 3q, x equal to 3q plus 1, now let us square on both the sides, x square equal to 3q plus 1 whole square. So now we have to apply the a plus b whole square formula, that is a square plus 2ab plus b square. So that is equal to 3q whole square, that is 9q square, plus 2ab means 2 into 3q into 1, that is 6q, and b square is, here b is 1, so that is 1 square equal to 1. So now if we consider 3q square plus 9q square plus 3q, 9q square plus 6q. Now if we take common 3 over here, then we will get 3 into 3q square plus 2q, and 1 will be remaining aside. So now we will consider that 3q square plus 2q as m. So then it will be in the form of 3m plus 1, where for some integer m, where m is equal to 3q square plus 2q. Okay. Now let's take the third part, that is x equal to 3q plus 2. So if x equal to 3q plus 2, then squaring on both the sides, it will be x square equal to 3q plus 2 whole square. So now again apply the a plus b whole square formula, that is a square plus 2ab plus b square. So 3q whole square is 9q square plus 2 into ab means 2 into 3q into 2, that is 12q plus 2 square, that is b square, that will be 4. Now let's split this 4 as 3 plus 1, because we have to make in the form of 3m plus 1. So we have to split this 4 as 3 plus 1. So now if we take 3 common here, then 3q square plus 4q plus 1, and 1 will be outside. Now we will replace this 3q square plus 4q plus 1 as m. So that will be in the form of 3m plus 1 for some integer m, where m is equal to 3q square plus 4q plus 1. Okay. So what we got, that square of any positive odd integer is either in the form of 3m or 3m plus 1. So we proved that for some integer m. Now coming to the next problem. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8 for some integer m. So same way we need to prove it. So now in this case we have to find the cube. So let x be any positive integer. So x cube should be in the form of 9m or 9m plus 1 or 9m plus 8. So here, since divisor is 9, if we take a look at a equal to b cube plus r, so b is here 9. So the possible remainders will be from 0 to 8, as we know that remainder value will be vary from 0 to less than b, that is less than divisor, so less than 9. So the possible remainders will be here 0 to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can write this in the form of 9q, 9q plus 1, 9q plus 2, 9q plus 3, 9q plus 4, 9q plus 5, 9q plus 6, 9q plus 7 and 9q plus 8. Now let's consider the divisor as 3. So if the divisor is 3, then what are the possible remainders? That will be 0, 1, 2. So that is in the form of 3q, 3q plus 1 and 3q plus 2. So let x be any positive integer and b is here we are considering as 3. Now after applying the Euclid's division algorithm, we will get x equal to 3q, x equal to 3q plus 1 or 3q plus 2. Now if we consider x equal to 3q, then x cube will be 3q whole cube. So that is equal to 27 whole cube to the power cube. So now that we can represent 27 as 9 into 3. So 9 into 3q to the power cube. So if we consider 3q to the power cube as m, then we can represent it as 9m for some integer m, where m is equal to 3q to the power cube. Now let's consider the second case. That will be x equal to 3q plus 1. Okay. So in this case, if we do the cube on both the side, x to the power cube equal to 3q plus 1 to the power whole cube. Now here we are going to apply a plus b to the power cube formula, that is a cube plus 3a square b plus 3ab square plus b cube. So that is equal to 3q to the power cube whole cube plus 3 into a square b means a is 3q over here. So a into 3q whole square into 1 plus 3ab square, a is 3q. So 3 into 3q into 1 whole square plus 1 to the power cube. Now simplify it. So it is 27q to the power cube plus 27q square plus 9q plus 1. Now we will keep 1 aside. Now from this we will take 9 as common. Then we will get 3q to the power cube plus 3q square plus 1 q, and 1 will keep aside. Now replace this 3 whatever is there within the bracket part as m. So 9m plus 1 for some integer m, where m is equal to 3q to the power cube plus 3q square plus q. Now let's take the third case, that is x equal to 3q plus 3q plus 2. Now let's cube on both the sides. So again we have to apply a plus b whole cube formula, that is a cube plus 3a square b plus 3ab square plus b cube. So 3 cube to the power whole cube plus 2 into a square means 3q whole square into 2 plus 3 into a is 3q into b square is 2 square plus 2 to the power cube, that is b cube. Now if we simplify, it is coming 27q to the power 3 plus 54q square plus 36q plus 8. Now we will got the 8 over here. So now we have to make sure that the previous part we can, if we represent it in the form of 9m. So let's take 9 common from here. So 3q cube plus 6q square plus 4q plus 8. So now replace this whatever value is there as m. So 9m plus 8, where m for some integer m, where m equal to 3q cube plus 6q square plus 4q. So what we can see that cube of any positive integer is in the form of 9m, 9m plus 1 or 9m plus 8 for some integer m. Okay. So in this case, we have not considered the divisor as b as 9. Instead, we can consider as 3, and we can prove that it is in this form. Now coming to the next question. Now let's take a look at the next question. Prove that product of 3 consecutive positive integers is divisible by 6. So this is a bit different type of question. So we have to prove that the product of 3 consecutive positive integer which should be divisible by 6. So first we need to understand what do we mean by consecutive positive integers. Consecutive positive integers means the numbers that are in sequence. Like if we say 2, 3, 4, so they are consecutive. Okay. So in general, we can represent the consecutive positive integer in the form of, if we consider the middle number as n, then the previous number will be n minus 1 and the next number will be n plus 1. So consecutive positive integers will be n minus 1, n and n plus 1. Now by Euclid's division algorithm, we know that here we have to prove that divisible by 6. So here we are considering the divisor as 6. Okay. So a equal to 6q plus r, where 0 less than equal to r less than 6. So the possible remainders are 0, 1, 2, 3, 4 and 5. Now if a equal to 6q plus r, so what are the possible values? So that is a equal to 6q plus 0, that is 6q, or 6q plus 1, or 6q plus 2, or 6q plus 3, or 6q plus 4, or 6q plus 5. Okay, where q is some integer. Now let us consider case number 1, that is a equal to 6q. So if we consider that n equal to 6q, okay, so here a we have considered a is the, if we consider that n is the middle one as the 6q, okay, then n minus 1 will be 6q minus 1 and n plus 1 will be 6q plus 1. So we need to find the product of three consecutive positive integers. So that is n minus 1 into n plus 1. So now replace the values over here. So 6q minus 1, 6q and 6q plus 1. So if we take a look that in these three products, 6 is common, right? So if we take out this 6 and put everything inside another bracket, and if we consider that this entire thing as m, then we can represent it as 6m, where m is equal to 6q minus 1 into q into 6q plus 1. So here the above result is the multiple of 6. So this is case number 1. So we can clearly tell that it is divisible by 6. Now let us consider the second case where a equal to 6q plus 1. So that means n equal to 6q plus 1. So n minus 1 will be 6q plus 1 minus 1, that is 6q. And n plus 1 will be 6q plus 1 plus 1, that is 6q plus 2. So n minus 1 into n plus 1 is going to be 6q, 6q plus 1 and 6q plus 2. So here if we take common as 6 and put everything inside another bracket, now we will replace this entire thing with m, where m equal to q into 6q plus 1, 6q plus 2. So we can clearly see that this is also the above result is multiple of 6. So hence we can say that it is divisible by 6. Now we will consider case number 3, where we are going to consider n equal to 6q plus 2. So n minus 1 will be 6q plus 2 plus minus 1, that is 6q plus 1, and n plus 1 will be 6q plus 2 plus 1, that is 6q plus 3. So n minus 1 into n plus 1 is going to be 6q plus 1, 6q plus 2 and 6q plus 3. Now 6q plus 1 we will keep as it is. Now from the second one, if we take 2 as common, then it is going to be 3q plus 1, and from the third part we are going to take 3 as common, then it is going to be 2q plus 1. Now if we combine 2 and 3, then we will get 6, and we will keep everything inside another bracket. Okay. Now we will just represent this as m, okay, whereas m is equal to the entire thing. So we can clearly see that it is also the multiple of 6. That means it is divisible by 6 as well. Now case number 4. So here we are going to consider n equal to 6q plus 3. Okay, so n minus 1 is going to be 6q plus 3 minus 1, that is 6q plus 2, and n plus 1 will be 6q plus 3 plus 1, that is 6q plus 4. Okay, so now n minus 1 into n plus 1 will be 6q plus 2, 6q plus 3 and 6q plus 4. Now from the first part, if we take 2 as common, then it will be 3q plus 1, and from the second one, if we take 3 as common, then it will be 2q plus 1, and third part we will keep as it is. So if we combine 2 and 3, we will get 6. So 6 into, and everything now we will put inside another bracket. So it is also in the form of 6m, where m is the entire thing. Okay, so we can clearly see that it is also the multiple of 6. That means it is divisible by 6. Now we will consider case 5, where n is equal to 6q plus 4. So n minus 1 will be 6q plus 4 minus 1, that is 6q plus 3, and n plus 1 will be 6q plus 4 plus 1, that is 6q plus 5. So n minus 1 into n plus 1 will be 6q plus 3, 6q plus 4 and 6q plus 5. Now from the first part, if we take 3 as common, then it will be 2q plus 1. From the second part, if we take 2 as common, then it will be 3q plus 2, and third part we will keep as it is. Now combine these 2 and 3, we will get 6, because our main target is to make 6 as a multiple. Now we will put everything inside another bracket and we will consider it as m. Okay. So now where m is the entire thing, so we can clearly see that the above result is the multiple of 6. That means it is also divisible by 6. Now let us consider the final case, that is if n equal to 6q plus 5. So now n minus 1 will be 6q plus 5 minus 1, that is 6q plus 4, and n plus 1 will be 6q plus 5 plus 1, that is 6q plus 6. So n minus 1 into n and n plus 1 will be 6q plus 4, 6q plus 5 and 6q plus 6. Now we will keep as it is. Now we will take, because our main target is to get 6. So since we got 6 from the last part, so we don't need to split the other part. So now we will take 6 as common over here and it will be q plus 1. So now if we take 6 in front of everything, then put everything inside another bracket. So we will get 6m. So where m is the entire thing, and we can see that it is also in the form of multiple of 6. So it is divisible by 6. Okay. So here we have so many cases we need to show, because whenever there are multiple remainders, we need to show all the cases. Okay. So it is divisible by 6. Now, if the problem is given in this way, that for any positive integer n, prove that n cube minus n is divisible by 6. So it is the same problem that we did earlier. Why I am telling? Because n cube minus n, we can represent it as n into n square minus 1. And you know n square minus 1 means n square minus 1, we can represent it as a square minus b square formula. So that is in the form of a plus b into a minus b. Now if we replace that, n square minus 1 will be n plus 1 into n minus 1. So now these, if you check, these are basically, if you rearrange it, then it is basically n minus 1 into n plus 1. So that means 3 consecutive positive integers. So it's the same, whatever we have done in the previous way we have proved, the same problem. If the question is given in this way, we have to apply the same thing. But first we need to prove this one, that these are the 3 consecutive positive integers, then we can prove the same way. Okay. So this question can be come in 2 ways. The earlier one, that proved that the product of 3 consecutive positive integers is divisible by 6, or it can also come in this way, that prove that n cube minus n is divisible by 6. So in both the ways, first in this case you have to prove that these are the 3 consecutive positive integers, then you can prove in the same way. Okay. Hope this is clear. So that's all for today's video. So if you like it, please hit the like button. If you have any comments on this video, then you can put it in the comment section, and please share with your friends, and to get the new videos that will be uploading. So for that, just subscribe to my channel. For that, you just need to press the bell icon, and then you will get notified for the upcoming videos. Okay. So that's all for today. Thank you. Bye bye.